Now let me introduce implicit differentiation. And what does this mean? Well, first let me go back to explicit differentiation, which is what you have probably been doing. Whenever we're given a nice little function y equals f of x, it's easy to take the derivative of such a thing. We're just doing dx of y, and we can take the derivative of x squared, which is 2x, the derivative of x, which is 1, and we're done. dy dx, which is the derivative, is just 2x plus 1. So this is essentially explicit differentiation. Why is it explicit? Because we know the variables that we're dealing with. We are taking the derivative with respect to x. But sometimes it's not going to be as obvious, or we won't be able to differentiate explicitly. So we want to differentiate, let's say, x squared plus y squared equals 10 with respect to x, but we don't have a function like this, y equals f of x, anymore. So that's when implicit differentiation comes into play. And how does it work? It's not as hard as it seems. Please bear with me throughout the explanation. Hopefully it'll make good sense to you. We would still want to find the derivative with respect to x. So I'm going to take d dx of both sides. That's the type of notation that I'm going to be using right now. And we're going to have d dx of x squared plus d dx of y squared equals d dx of 10. The derivative of 10, since 10 is just a constant, it's just going to be 0. And that was a 10 before, by the way. There we go. Okay, so in here, d dx of x squared, that's just the derivative of x squared with respect to x, which is just 2x using the power rule. But now we hit a bit of a roadblock. How can we take the derivative of y squared with respect to x? Well, that just doesn't work, does it? Here's what we're going to do with implicit differentiation. We're going to change this d dx to d dy of y squared. How can we do that, though? We're just going to have to multiply this by a particle dy dx, and it's still equal to 0. And how does that work? Well, now I can take the derivative of y squared with respect to y, and I'm just going to multiply everything by dy dx, which eventually we want to isolate to find the answer. Okay, but how did d dx turn into d dy times dy dx? Well, let's take a look at this. D dx is equal to d dy over dy dx, because these can cancel out. Then we just get d dx. How fantastic. So now we can take the derivative of y squared with respect to y, which is just going to be 2y. That's it. But we are still multiplying the 2y by dy dx. And dy dx is essentially the derivative with respect to x of the relation. Still 0 on the other side, so let's isolate dy dx and we'll have the answer. So subtract 2x from both sides of the equation. So this is going to happen, by the way, every single time that we are differentiating with respect to another variable. Then I can divide both sides by 2y. So dy dx is equal to negative x over y. And at this point, we're done. This is what we were looking for. We have successfully differentiated x squared plus y squared equals 10. dy dx is negative x over y. That's it. So now I strongly suggest you scroll down, try some questions, or click on the questions to watch videos explaining them. It might take a couple of examples that you can take a look at and watch to learn and become comfortable with implicit differentiation. Good luck.